Okay, ladies and gentlemen, so this video is going to be about square rooting. So what I want to go over here is, first of all, how we square root these type of numbers, which is pretty simple. But then also how we square root other numbers. So these numbers are simple, and the reason they are simple to square root is because they are perfect squares. So for example, the square root of 9, we know that 9 is a perfect square because 9 comes from 3 times 3. Right? So the square root of 9 would be 3. That's a pretty simple one. Same thing with the square root of 25. The square root of 25, because 25 is made up of two factors, 5 times 5, the square root of 25 would be 5. If we look at the square root of 36, same thing. 36 is a perfect square because it's made up of 2 factors, 6 times 6. So the square root of 36 is going to be 6. Just like the square root of 49 will be 7, because 7 times 7 is 49. And we can go on and on. We can go to the square root of 64, square root of 81, square root of 100, and so on, right? But what I want to get to today is square rooting numbers that are not perfect square, like 9. It's a perfect square. So square rooting a number that is not 9, for example. But what about a number like the square root of 27? So if I take the square root of 27, so when we look at the square root of 27, I want to go over two different things. One is to approximate it, and the other one is to be precise, so, or to simplify it, right? So we'll talk about approximation in a bit, but let's talk about simplifying the square root of 27. So when I look at a number like 27, 27 is not a perfect square, right? Because there's no one number multiplied times itself that gives me 27. So for example, like I know that 9 is a perfect square because 3 times 3 is 9. So 3 times itself gives me 9, which makes 9 a perfect square. Same thing with 25. 25 is a perfect square because 5 times itself, 5 times 5, gets me 25. There is no number times itself that gives me 27, right? No whole number times itself that gives me 27. So what I'm going to do instead is I'm going to look for 2 factors of 27. So I'm going to turn this into the square root of 2 numbers that are being multiplied. So I need 2 numbers that are being multiplied that when I multiply them I get 27. So I have a couple of choices. Actually, I have like 27 times 1, right? So square root of 27 times 1 could be 1. So let me put a little thought bubble here. This could be 27 times 1. Another set of factors that this could be is 9 times 3. And I think that's about it, right? So what goes inside here is either going to be 27 times 1 or 9 times 3. I'm looking for one of those 2 factors to be a perfect square. So 27 is not a perfect square. 1, I guess you can argue is a perfect square, but then I'm just going to be left with the square root of 27 all over again. So let's try 9 times 3. 9 is a perfect square. 3 is not, but 9 is a perfect square, as we saw over here. So I'm going to go with 9 times 3. And the reason I want one of these 2 numbers to be a perfect square is because I want to square root that perfect square. So now that I have a perfect square, I'm going to rewrite this as 2 separate square roots. So the square root of 9 times the square root of 3. This right here is exactly the same as this, which is exactly the same as this. But the reason I want to write it this way is that now I get the square root of 9. And 9 is a perfect square. So instead of writing the square root of 9, I know that this square root of 9 is 3. So I can rewrite this expression as 3 times the square root of 3. Because the square root of 9 is 3. Now I don't need the square root symbol anymore because I just square root it. Square root of 9 equals 3. Square root of 3 stays the same like this. So my simplified version of the square root of 27 is 3 times the square root of 3. This right here. Let's do one more. So let's say now that I have the square root of 50. I know that 50 is not a perfect square because there is no one number times itself that will give me 50. I know that 7 times 7 gives me 49, and I know that 8 times 8 gives me 64, but there's no number times itself that gives me 50. So what I'm going to do is I'm going to rewrite 50, or the square root of 50, as the square root of a number times another number. I want one of these numbers to be a perfect square. So let's think of factors of 50, right? So factors of 50 could be 50 times 1, which I'm not going to use because anything times 1 is not really going to help me. Another factor could be 25 times 2. Another set of factors can be 5 times 10. And now what I want to see is which of these sets of factors has a perfect square. So 50 is definitely not a perfect square, so this is not going to help us at all. So this guy's gone. 25 and 2, 25 is a perfect square, so that's going to help us. But let's look over here just in case. 5 times 10, 10 is not a perfect square, 5 is not a perfect square, because nothing times itself gives me 5, nothing times itself gives me 10. So the perfect squares that we have here are 25 and 2. So I guess I'm going to be using 25 and 2, and I'm going to put them right here. So now what I have is the square root of 25 times 2. I'm going to rewrite this as separate square roots. So the square root of 25 times the square root of 2. Square root of 25 times square root of 2. Of these two, I know one of the square roots. Like, I don't know the square root of 2 because 2 is not a perfect square. But I do know the square root of 25. The square root of 25 would be 5, right? So I'm going to write this as 5 times the square root of 2. Or I can write it as 5 square root 2. They both mean exactly the same thing. So the simplified version of the square root of 50 would be 5 and the square root of 2. Let's do one more and see if this time you can do this one on your own. Okay, so here we have the square root of 48. I want you to press pause right now and try to figure out the simplified version of the square root of 48. Okay, now that you're done, let's go over the square root of 48. By the way, if you're cheating and you just didn't press pause and you're just waiting for me, shame on you. You're not going to understand this by the time I test you, and believe me, I will test you. So, let's move on. Okay, so now we got the square root of 48, so I'm looking for factors of 48, because what I want is I want two numbers inside the square root, two factors, something times something else. And I want these two factors, well, first of all, let's think of factors of 48. Okay, so maybe 6 times 8, right? 6 times 8 would be 1. Another would be 12 times 4. 12 times 4. Another one would be, I'm not even going to think of 48 times 1 because times 1 doesn't really help us any. So another one can possibly be, let's see, we got 12 times 4, we got 6 times 8. Oh yeah, we got 24 times 2. Let's think of one more, and let's put a little thought bubble here. Oh, we also have 16 times 3. Okay, so now let's look at all these factors. So I'm looking at all these factors here and seeing if I can see any perfect squares. 24 is not a perfect square because nothing times itself gives me 24. 2 is not a perfect square because nothing times itself gives me 2. So these guys are gone. 6 is not a perfect square. because nothing times itself gives me 6. 8 is not a perfect square because nothing times itself gives me 8. So these are gone. So now we're left with either 16 times 3 or 12 times 4. Let's see. 12 times 4. 12 is not a perfect square because nothing times itself is 12. 4 is a perfect square because 2 times itself, 2 times 2 is 4. So this might be a possibility. Let's look over here. 3 is not a perfect square because nothing by itself or times itself gives me 3. 16 is a perfect square because 4 times 4 is 16. So I have this perfect square here, and I have this perfect square here. When you have two different perfect squares, then you want to go with the highest perfect square. So in this case, it would be 16. So I'm not going to use 12 times 4. I'm going to use the higher perfect square, which would be 16 times 3. So I'm going to put 16 times 3 inside this square root symbol. So now we have the square root of 16 times 3, which I'm going to write as the square root of 16 times the square root of 3. And between these two, I know the square root of one of them. I don't know the square root of 3, but I do know the square root of 16. The square root of 16 is 4. So what I'm going to be left with is 4 square root 3. Okay, so what I'm going to do now is I'm going to leave some right here for you to do, and then I'm going to jump over here to show you what the correct simplification is, and hopefully you can get there on your own. So here are the 3 square roots that I want you to simplify, and what I want you to get to is what I'm about to place right here. So you should be left with 6 square root 2, 7 square root 3, 5 square root 3. Another way to say this would be 6 radical 2, 7 radical 3, 5 radical 3. And if you really want to be a cool algebra person, or a cool algebra, then this would be 6 rad 2, 7 rad 3, 5 rad 3. Okay people, I'll see you on the next video.